Hi, my name is Bhupesh Arya. I am Jboss SA based out of India, and today I'm going to talk about M2M, that is machine to machine or Internet of Things, using Red Hat solutions. Uh, you heard, you may have attended a session from my colleague Christina, who also covered a similar topic. So you may find some of the things that have already been covered. I will also elaborate a few more details about the use cases for M2M, different components that are involved, and we'll cover a few of the partner frameworks or solutions that are available uh, with whom we can align to sell the Red Hat solutions jointly. So, starting from a business context, as we know, everything can be on the internet. It's apart from the regular mobile devices and your desktops and your iPads. There's a huge growing market where there are other devices which are exploding and getting connected onto the internet. Uh, yeah, there are different estimates being given by different uh, analysts, and we're talking about 15 billion to 1 trillion things uh, by 2020 that will get connected with the internet. So here are a few examples. We're talking about, say, for example, a smart meter, which can keep on sending some details back to the data center, and it's permanently connected through the internet. Or it could be a device or a smart connected light, which is again not connected to the internet directly, but through a hub or a smart hub, sending data back to the data center so that it can be remotely controlled. So, how are enterprises leveraging IoT or M2M? Obviously, one of the ways is to optimize the utilization. Say, for example, for my smart city, I'm using remotely controlling all my different devices, be it lights, be it my air conditioning, or other systems within my building or my city. Uh, the other is obviously related to that is a remote operation. Since this is gets connected, so we are also talking about smart homes where I can remotely control the security of my home, or even remotely switch on my air conditioning or switch off my air conditioning. So I'm remotely controlling all those devices through the internet. And obviously, enterprises are leveraging it. The models, it's still a very emerging market through a pay per use model. Or we are also talking about extending the digital services or providing digital services or content through these. So moving on to next slide. Uh, Once an enterprise understands that this is something which is a new business model and they can make more money out of it, and typically, at least I have been interacting with a few telcos in India who have been already, a couple of them have already been doing it, and there are a couple of others who are still in the exploratory stage. So the questions that come to the mind, their mind are, okay, okay, I'm interested. This makes sense to me, but I have a lot of questions. What are the costs of application development? How much it's going to cost me? Or whether it's going to scale, because you're talking about a huge number of devices, the velocity and the volume of data is going to be so high. Uh, will the system that I buy will be scalable enough to handle those volumes as well? How do I integrate this with my existing applications and obviously different customers that I have? It could be enterprise customers or individual subscribers who want to utilize this service. How do I charge them? How do I bill them? So there are so many questions, and then obviously there's a question of how do I make sure that there's a comprehensive management environment around it. How do I make sure? How do I ensure there are different types of devices that will come in to get connected to my infrastructure? So how do I manage those different protocols, and how do I keep them up to date? And this entire diversity is so huge. the customers can really it can be really scary for them. On the technology level, as I said, different devices, different protocols with no standardization. So what should I do? How should I go about doing this? So we have seen this picture earlier in our presentation the other day from Christina. At a very high level, the way it looks like is, if you see at the bottom are different devices which are sending data at different protocols. The first layer that typically comes is a device connectivity component. It could be as a hub or an aggregator, or it could be that individual devices are directly sending the data uh, back to your M2M, if you may want to call it, as a business enablement platform. So you need to have different adapters to take care of different protocols, to take care of different devices. So that's the first layer, is the data capture layer or the device connectivity component. And obviously, once the data is connected, uh, then you need to push the data up into the application integration layer or the application layer, where you correlate different events, you capture different types of data, and based on that, you may want to generate alerts, or you may want to expose that data, or you may want to do analytics of the data as well, and expose it to the different types of applications, the end use applications. Say, for example, it could be for a telecom infrastructure company, you're talking about a smart tower management, or it could be healthcare or any other application. So moving on, these are the different use cases, or how getting into further details of how it looks like. The first layer that we talked about is how do you receive data? Like, there will be different scenarios where you're talking about, in certain cases, the device sends data only in case of special events. Whereas there could be other use case scenarios where you're talking about there's a real-time data stream that keeps on coming from the device. And obviously, there will be situations where you need to analyze this data on a need to do basis, and you need to have some sort of a data processing and a data warehouse capability. Uh, the next use case is the data delivery to applications. Now, again, there are different types of, depending upon the end use case, there could be scenarios where one device is sending data that could be utilized for different business applications, or there could be a requirement that different devices are sending data, and you need to aggregate that data and expose that data to a single business application, and it can be used as a combined asset. So in this case, you're talking about reusing the devices by different applications, or you are aggregating different devices which are being used as a combined asset for a particular type of a business application. These are different use cases. Again, depends upon individual use cases and requirements. Now, the third requirement that could possibly happen in an M2M environment is where you need to send data back to the devices. Again, one of the options obviously is to send the data directly from the business application to the device. Obviously, it has its own set of challenges. You need to manage different protocols. You need to manage the scalability aspect of it, and obviously the load that directly gets on the business application. Or the other option could be there is a application integration layer or a data processing layer. All the business applications do is push the data to that data processing layer, and that layer takes care of pushing that data to all the relevant devices. All right, so other use case is application mashup. So here we are talking about one particular M2M service provider, say for example a telco who is hosting this type of a platform, may provide certain set of applications, but there could be a possibility that they may use some of the services that are external to them as well. And there could be even within the service provider, there could be different services that they may be offering. There might be a need of a mashup of these services, and that is where again the application integration layer through a service registry which keeps track of all these different services, and an orchestration layer to basically support composing different services or a bigger service out of it through by using these different services. So you need to be the platform needs to be able to support the service registration capability. It should be able to support the mashup of different types of services and events. At the same time, it should be able to propagate real-time business events to the M2M platform, and obviously taking care of your security and service discovery as well. Then obviously there are some standard use cases from an operational standpoint. Obviously you need to integrate an application, or you need to onboard a new application that comes across to you. You need to provision this service, make that application available to the consumers. How do you do that? There's a question of managing the entire life cycle of the device. How do you activate the device? How do you configure the device? And then basically manage the entire life cycle. At the same time, a couple of other things. Say, for example, how do you keep track of all the audit logs and what all data that is being captured, and whatever actions or alerts that are being generated. You need to keep track of all of that, and obviously support for internationalization as well. So coming back, if you look at the big picture, so there are three main components that you could see, or maybe four. On the left-hand side, you see the device or the asset. It could be generalized as an asset. That's one part of it. That's basically, and then you need to have some sort of a communication network. It could be a mobile network, or it could be a wireless, wireline network, whatever. So there needs to be a network connectivity back to the M2M business enablement platform, which provides you some of these things that we talked about earlier, needs to provide some of these or needs to implement some of these use cases, from application management to device management and data management, doing some analytics as well. And then this platform needs to expose some sort of services, web services, which can be based on SOAP or REST. And then on the right-hand side, you see this is how it gets exposed to the customer. It could be your enterprise customer, a B2B or a B2C, and taking care of different modules within that from a sales, marketing, and a product management perspective. Yeah, getting into a little more technical from an architecture standpoint, this M2M business enablement platform. On the top, you see there are different business applications which are exposed to the B2B or B2C customers. On top, you need to have a portal, which is the primary access layer for most of the customers. There needs to be a service layer. It needs to be a SOA-based architecture where you can orchestrate and compose services out of the different services that are available to you. Below that, you need to have some sort of an application integration layer. So you need to have some sort of an ESB going maybe, and some sort of a BIPL capability. We'll get into those technology details in the later slides. You need to have some sort of a data processing, data connectivity, or maybe taking care of your protocols from the devices, and some sort of analytics engine going on. And then obviously there's at the bottom you have the device connectivity layer, depending upon the type of network through which the device is connecting. This data needs to be made available to this business enablement platform. But that's generally considered outside the scope of the M2M business enablement platform. So getting into the nitty-gritties from our perspective, from a Red Hat perspective, some of the components that are of interest to us or fit into this type of a solution. Obviously, you need some sort of a enterprise service bus, as I talked about. We need to have some sort of an analytics engine. We don't have a direct play there. We need to have some sort of an event processing and a rules processing. where you need to correlate the data that is coming from different devices or from the same device at different intervals, and correlate those different events and define the events that may be of interest to the business application or to the end user, and obviously define rules on top of it. So the enterprise service bus is primarily helps you connect with the devices, helps you connect with the other enterprise applications of the service provider as well. And from the app layer, obviously, you need to have some sort of a portal or an application server to basically render some of these services to the B2B or B2C users. And some of the external applications that need to get connected to this enterprise service bus are obviously listed at the bottom. Billing, CRM, ERP, these are some of the standard ones that are required to be integrated. So obviously, it needs to be a SOA-based architecture based on open standards so that it's flexible, because you don't know what those new applications will be from one perspective, and on the other hand, the devices and the range of devices and the protocols that they support, it's growing by the day. So you need to make sure it's open enough to basically embrace these changes. So data processing and device connection. So that's the first layer, as we talked about earlier. So there are basically needs to have two different components. So the first layer is the device connection layer. So how do I connect to different devices? And that's where you need to have a tool or a software which can provide the capability to support multiple protocols, like MQTT and AMQP. And handle it in a very modular fashion. And then once the device gets hooked up into the business enablement or M2M platform, the next thing obviously what you need to do is process the data. And as I said earlier, that's where you need to pick up different business events, correlate those events, whatever is of interest to the end user or to the business application, and process all that data. Could possibly be related to, again, doing some real-time analytics as well, and then through the integration layer, expose that data to the business applications. So this approach obviously gives you a very clean separation of device connection with the device connection layer with the data processing layer. And it gives you the capability to scale. And since the velocity and the volume of data that will be coming through devices is going to be very, very high, you need to have a very, very scalable and an asynchronous architecture in place as far as the device connectivity layer or the data capture layer is concerned. And this is just a very simple illustration of one of the use cases where automobile industry is using it for their vehicle maintenance. And it just shows you some sample how this APIs that are exposed from the platform may look like, where you have a certain lifecycle functions on the devices, where you say get the device or modify the device status or send the message or get the message kind of stuff. So this is just to illustrate the life cycle of a device, on how the device that gets connected to the M2M platform goes through the life cycle. The platform needs to have the capability to make sure that whenever there's a new device that gets connected, you are able to activate that device, you're able to configure that device using the platform, and finally maybe deactivate it as long as and when the service is not being utilized anymore. So this is the picture that you might have seen which Christina had shown the other day. So that's showcases the Jboss components that fit into the overall architecture. On the left-hand side, you see the different types of use cases in the medical space, medical devices or industrial machines, for distribution or delivery vehicles, to energy monitoring or even tower management. So the first layer that comes into picture from a device capture or a data capture layer, the technology that fits in very nicely, and then it has the capability to scale as well as provide asynchronous communication, is Jboss AMQ, which has a wide variety of protocol support from MQTT to STOMP to AMQP. So that's your the first layer for the data capture layer. Then obviously you have the Jboss BRMS, which provides you complex event processing as well as the rules engine capability to define different events and correlation of events which are of interest to you, define rules based on those events which you want to expose to the business applications. Integration layer, as we talked about, primarily provides you connectivity with other enterprise applications like that already exist in a service provider environment, like a billing, CRM, ERP, and other systems. Jboss data virtualization. This comes into picture when you may want to do a mashup of the data. That is the streaming data that is coming through these different devices with some of the data that may be available in your environment already, say, for example, through Hadoop or through existing enterprise applications, and you want to do some analytics on the combined data. That's where data virtualization along with data grid, and data grid will give you the capability to cache that combined data, and then will hide the complexity, or rather improve the performance of your analytics engine when you need to do such analysis. On the bottom, obviously, there's a Red Hat storage component which supports, which is a Hadoop compatible storage. So you can store a lot of this data, which grows very, very rapidly into a Red Hat storage kind of a tool. And obviously, the underlying infrastructure, RHEL and REV, can obviously fit in very nicely in this kind of an environment as well. So just reiterating which we said on the previous slide, Jboss AMQ is the device data capture layer using MQTT, AMQP, and maybe other protocols as well as required. Jboss BRMS for doing complex event processing, event correlation, and data mashup rules. Data grid for caching device data for real-time analytics. Fuse or maybe Fuse ServiceWorks for providing orchestration of your services, integration gateway for enterprise applications. Jboss data virtualization for combining data sources, not only the device data that is streaming data that is coming to you, combine that with your existing enterprise data sources and do analytics based on that. Jboss EAP/portal for the end user application platform. RHEL and REV for operating system and virtualization across layers, and Red Hat storage as your Hadoop compatible storage. So as you can see, there's a whole lot of Red Hat technology and primarily Jboss technology which can be positioned or is being positioned if this kind of a solution gets a buy-in from the customer. So finally, summarizing, it's basically a framework where you can enable M2M capabilities. One of the things that I wanted to talk about is, like, we have been working with a telecom company here in India, where we have been positioning this kind of a framework or a solution, working along with the partner. So the partner has already developed some sort of solutions around it. They have some bits and pieces already in place using one or more of these Jboss technologies. So there are a couple of partners that I've been interacting with, I'm sure, and in other regions, I've been talking to some of the people. There are a lot of local partners who are offering these kind of M2M frameworks. So my view is it's much better to work along with these partners. The acceptability of Red Hat solutions becomes much more better and easier working along with these partners. And obviously, they bring along a lot more value, and we are more like the technology enablers as far as the end customer or the service provider is concerned. So M2M enablement framework, it's a framework so that you can grow, your business applications can grow, or your devices, you can add a plethora of devices, which exposes standard interfaces with obviously the security capabilities built in with a lot of asynchronous scalable architectures to capture the data and some of the other components that we talked about. So that's what I've been working with a couple of partners and a telecom customer here in India. I hope to close this opportunity with them pretty soon. We'll share the details with you. Unfortunately, I can't take any questions, but I'll be more than happy if you can drop me an email. I'll be more than happy to help you, if whatever is required. Thank you.